Once again, we are all welcome to this class. This is statistics for management. Right, so I want to welcome you once again, and today we'll be looking into the probability. And when we are talking about probability, you can tell us, what do you know about probability, please? Anybody? If you have idea, you can raise up your hands, then we can give you the mic to talk. What is probability? I don't need definition from your textbook. Just tell us generally, what is probability? Maybe I should call name. Ibidapo. Ibidapo. Okay, I can see Ugo. Ugo, go ahead.
Okay, good morning, sir.
Morning, my brother.
Okay, the only way I can put probability is all about chances.
Chances, okay.
Occurrence of chances. That's the only way I can put it from my own point of view.
Okay, well again. Okay, Wale.
Good morning, sir. Thank you for the opportunity. Probability deals with, from my own knowledge, the analyzing, measuring of the possibility of an event occurring.
Somebody said chances, you said is an opportunity or chances of what? Event occurrence. Okay.
Yes, a possibility.
Possibility.
Of an event occurring.
Okay.
Yes, the analyzing, measuring of the possibility of an event occurring.
Okay. Okay. Muraina.
Good morning, sir.
Morning.
Yes, sir. Probability, according to my own understanding, is the likelihood of occurrence of an event.
Likelihood. Let's just take care of those words. Likelihood of event of occurrence. Okay, go ahead.
Yes, sir. That is my own understanding, sir.
Okay. Mr. Solomon, over to you.
Hello, sir.
Hello, sir.
Probability is something that may happen if you, for example, for a man or woman, you may have a man or woman as a something that is certain thing will happen. If in a coins, we have head or tail. Something may be head, you may be head or tail. It will not. You cannot. As a child of as a woman being, you cannot born a cat. Cat will that is 0. That the probability will be probability of 1. Something happen.
Like you are still talking about events. Thank you.
Yes.
Okay, thank you, sir. Okay, another person, Ayelabola.
Ayelabo.
Okay, Ayelabo, thank you.
Good morning, sir.
Good morning.
Yeah, in my own view, I think probability is uncertainty event.
Uncertainty event, okay?
Okay. That's my
own. Thank you. Johnson.
Good morning, sir.
Morning.
Okay. Probability can just be defined as uncertain actions that cannot be predicted.
Uncertain action that cannot be predicted. Okay?
Yes.
Ibrahim.
Yes, good morning, sir.
Morning, sir.
Sir, probability can be defined as a quantitative or can be defined as a probability quantified as a number between 0 and 1.
Okay, number between 0 and 1. Okay, that's good. Thank you.
You're welcome, sir.
Okay, you can hear different view from different people about probability, about how do we define it. At least you should be able to pick one or two things from what our people. Ibrahim, do you still want to say something? Please lower your hand. Okay, just raise up your hand from the Ibrahim. Okay, thank you.
I'm okay, sir. I'm okay, sir.
Okay. Elizabeth, what do you have to say?
Okay, sir. In my own understanding, I would say probability is possibility. It's a prediction of an event. Prediction of an event that occurs.
Okay, prediction of an event that occurs. Now, the key thing in probability, like one of us said, is the value of probability we are talking about is always between 0 and 1.
Okay.
What is the probability that is going to be rain today in your area? Remember, the probability in Enugu State that it's going to be rain might be different from probability that there will be rain in Borno.
True.
Are you getting the points now? So it depends on the science behind it that people will tell you, or some of us will do make some mistakes. We say, the probability is 100%. It's 100. Not knowing that you've multiplied it by percentage. That's why you say, oh, probability is 40-40. Oh, Arsenal will beat Chelsea. What is the probability? And the probability is 80-20. The person is talking about is saying that, listen, the probability in this case is 0.8. That is what the person is saying. It's actually saying the probability is 0.8. And while you are saying it will not occur 0.2. So when we come to probability, our lives, everything we do every day, it's all about probability. We wake up, we start. Okay, some of us that work in hospital, you discover at times they will tell you, what is the probability that this person will survive?
50-50.
Or the doctor will tell you, we have 50-50 chance. If you continue, if you want us, okay, can you please sign the consent form for us to continue this operation? Or is there anybody that will sign on your behalf? Now, if assuming they want to treat your hand, nobody will ask you that, oh, what is the probability? Or maybe you just eat your hand with something. They don't need probability in that case. They will just, okay, bring the balm, let's just rub it, it will be fine. But when it comes to something that you are not certain, you're not sure of what will happen, you are not sure of that event, that is when we begin to now use the probability of this, probability of that. So probability is not hard. Always believe is our way of life, is what we do every day, is what happens to us every day. So it's an event, like we said. Is an event. First of all, believe is an event. James, you raise up your hand. What's the problem? Any question? Unmute yourself, please. James Igbana. Yes.
Hello, sir.
Yes, hello. Any problem? Any question, rather?
No, I'm just joining the meeting now, sir.
Okay, no problem. You're welcome. Lower your hand.
Thank you.
Okay.
Sir?
So at the end of the day, you discover that the the probability, what we are talking about in probability is when we begin to treat some of the questions, you will see what it's all about. Then what are the principles behind it? What is the principle behind it? Do we have the axiom? Do we have the rules? Do we have the regulation? So these are the things I'll be sharing with us in today's class. So you are welcome once again. So my name is Dr. Segun Oke. And for those of us joining us for the first time, I believe you've been receiving the email from me, and you are welcome again. So let's look at this. I would not like to give us different notes or different, I'll just go straight to some of those important things. Like we said, what is probability? The first thing that comes to your mind is events. Look at the textbook. It said, probability is defined as a value between 0 and 1. That is, the probability of event cannot more than this we're talking about. It's between 0 and 1. So, what is the probability, like Mr. Solomon was saying the other time? He said that shows the likelihood of occurrence of an event. Event can be, are you going to win the game? That's an event. Can be anything. Everything we do. Okay, what is the probability that we are going to write? Okay, let me shock us now. What is the probability? I want somebody to tell. What is the probability that you are going to write an exam tonight? You are writing statistics tonight. What is the probability?
Zero.
Why will you say zero?
0.2. Because we are certain we won't be writing it today. Because we are certain we will not be writing it tonight.
Because exam timetable is not yet out.
Yes. So you have some clue, but you can't say 0. It might not be 0.
1.
Do you know? If I initiate it, I said, okay, I would like to test my student today by 10 p.m. Everybody, make sure you write. So what will happen? You will shout and you will still write it, yes or no?
Yes.
There are some things we don't have power over anyway. That's not, don't let us go too deep. Okay,
so
what's the probability that you are going to eat your breakfast?
1/2.
0.6.
1 because it's certain.
0.8.
0.8.
0.2. Somebody.
So, what's the probability that, bless you, are going to eat this morning?
So the probability is 1, no, because it must happen.
It is 1, sir.
The probability is 1.
Yes, ma'am.
Okay.
Because I'm sure that it
But
must
I'm sure, what is the probability that you are going to eat lunch today? Tell us. Rafat.
0.5.
It's 0.5, but you can, that means you might decide not to eat. 0.5, but you can,
yes, sir.
You might decide. Okay, so we have a lot of events that can give us. So what is the probability that this woman is worried? Everybody tell us. This the techno part.
1/2.
What's the probability? No, you don't need to on it. Don't worry. We can see you. What's the probability that she's worried?
1/2.
Oh, 1/2. Okay, somebody said 1/2.
1.5.
So what's your
1.5.
Yes, 1.5. Okay.
Be positive or negative. Positive and negative or negative. It can be, it cannot be.
Okay. So what is the probability that this woman is selling? Or she will
one.
You can see where she is now. So that's a probability. That's how probability can go. So Arasiola, we are promoting you, so you have to pay us for the adverts. Anyway. Okay, let's continue. So that's why I always tell people probability is not hard. All you need to know is, how do I define it? What are they saying? What is the law behind that particular probability? Once you know the definition, the rest is simple. Okay, let's move on. Let me continue. Let me share the screen. Now, if a value is 0, the event can never occur. That is the meaning. You can see, if the value is 0, it simply means that event will never occur. We will see a lot of events. So now, another one says, for instance, the probability that a mango tree will bear an orange fruit is what? 0.
0.
Are you getting it now?
Yes, sir.
The probability is 0. So another thing we need to check, if the probability is 1, it means the event is sure to occur.
Yes, no, I was saying as I'm coming.
The event will surely what? Occur. Then the probability that the man born a woman will die one day is what? 1. Whether
It's
you like it or
one.
not.
It's
One. Death is
That's
for any man like that. So let's continue. Can you please mute yourself? Mute yourself, please. Except if I have a question. Okay, let's move on. So we've explained the probability behind all this, and we all agree that the probability can only occur, you can only have 1 when you are sure that the probability will happen. Okay, let's look at the axioms. Some of the axioms about the probability. Axioms of probability. Let me just be using this as a probability. Let's take note of that. The axiom 1 says, let me say number 1. It says that for any event A, the probability of A is greater or equals to 0. Number 2, the probability of the sample space S is probability of S equals to 1. Number 3, if A1, A2, A2, A3, are disjoint, events, then probability of A, probability of A1 union A2 union A3 is the same, is equals to probability of A1 plus probability of A2 plus probability of A3. So in summary, what we are saying is, let me put it that, in summary, if A1 and A2 are disjoint events, then probability of A1 union A2 is equals to probability of A1 plus probability of A2. So we are talking about disjoint here. Then let's look at this. Please note. The probability, note that intersection, let me use this one. Means and union means or. So let's take note, because they can give you probability or these or this or this. They are talking about, anytime you see and in the probability, they are talking about intersection. But when you see or Ade or BC or Ibrahim or Asana, so it simply means they are talking about the union between them. So in a nutshell, the definition for this is quite simple. If they want to define it, they can say probability of A intersection B is the same thing as probability of A and B. Some people put it this way, probability of A, B. It depends. Then when they say probability of A union B, it's the same thing as probability of A or probability or B. So let's take notes of that. So let's move on. So we have different events that occurs, but let's look at this. So here they are talking about, unfortunately, some of the this is there is a particular issue here, typographical error, which might not be well when I'm explaining, but the axiom that I gave you, some of them are here, but I will still talk about it when we get there. So what is the properties? Let's talk about the property of probability. It said, the first one says, is derived from the definition. Probability of an event is defined as the value between, that is, what this saying is saying that, let's say we have an event E. So what is the value of the event E? Is that therefore the probability is that the probability can also not more than one. Please take note of that. Probability can never be, a probability is 5, probability is 10. No. Probability is always between 0, less or equals to probability of events, less or equals to 1. So I will also, let's just continue like this. I'll be explaining the probability here. So less or equals to 1. That's the first property that you need to know. Then if events are both mutually exclusive and collective exhaustive, then the sum of that probability of the event is equal to 1. The sum, look at it. That was a particular question they used to ask everybody. I will put the question on the chat, on the pool. You will see when we get there. It said the events that are mutually exclusive and collectively exhaustive are as follow. Number 1, male and female are sex of a child in a bath. Head and tail. That is, when you throw a coin, it's either you have head or you have tail, the other side. All of us that are used to this Ludo game, you know what we call a die. A die can only have how many faces? 1, 2, 3, 4,
5,
5 and 6. You remember where you normally draw it here like this. So by the time you put the number there, the number between this one will be 1 to 6. It cannot more than 1 to 6 all over the world. That is the nature of die. With the example, so they can ask you to find the probability that when I throw it, I'm going to have 1. When I throw it, I'm going to have 2. When I throw it, I'm going to have 3. You will see a lot of them. All the games that you see, all these Baba Jebu, Lotto, Raffle Draw, they are all principle behind of probability. So let's take note of that. So therefore, if events E1, E2, E3 to En are both mutually and collectively exhaustive, then you have this. That is, the sum of the probability will give you this. That is, when you add all that probability together, it will be equals to 1. So let's take note of that. The occurrence of either of 2 events, A or B, or both, is given. That is, there's something missing here that I would like to define in another way. If you check your notes, if you check your book, you will discover that something is missing. So who can tell us? What this place supposed to be is what? Anybody?
Union.
It's supposed to be
intersection.
wait. Wait now. We will see now. Probability of what?
Union first and union first. Last is intersection.
Okay. Wait, it's supposed to be
Union.
Probability of A union B, right?
Union B, yeah.
Okay.
Equal to.
Fortunately, I have to clean the board. So is equals to what now? Anybody? Based on the definition. Probability of A plus probability of B minus probability of A intersection what?
C.
Do you have C there?
Huh?
So it's supposed to be what?
B.
Is it B or C or A?
B. There's no C.
There's no C.
A intersection B.
It's supposed to be A intersection B.
B.
So that's the definition. So we will need this definition a lot in the course of this. So that's why you can see the reason why when I say focus, don't put yourself in the corner whereby you just rely on the books. Always come to the class. So now, but this hold when the two events can occur simultaneously. However, if the two events are mutually exclusive, what will happen? What is this place? This place is what? Probability of A
Union.
Is it intersection or union? Union B.
Union B
Is equals to probability of A plus probability of
B.
Now, they say something. However, if the two events are mutually exclusive, so the point of intersection here will be 0. That is the meaning. The point of intersection at this point is what? 0. That is why they put it in this way. That is, you can see, they explain it further here. They said, you should note that if two events are mutually exclusive, their intersection will be 0. Now, I'll give you a question now on a quick note. I have a question from your past question. Let me quickly bring it up. So I want everybody to quickly solve it. From that definition, you will know what I mean by that question. If you are smart enough, you will see. Me, I like to give questions in my class. I hope you enjoy it.
Yes, sir.
Yes, sir.
Yes, sir.
Just 1 minute more. I will just give you the question. Okay, you will see the pool now. I want everybody to answer the pool. I know some of you have been seeing the question before, but you don't know whether is the one or not. Pool 8, let's go there. Can you see it now? Can you see the question?
Yes, we can.
Yes, we can.
So can you solve it? Just put your answer in the chat. Let me see your answer from the chat. If A and B are mutually exclusive events with probability of A is equal to 0.3 and probability of B is equal to 0.5, then probability A union B, P of A union B is equal to what?
Yeah.
Go back on your link to everyone. So.
So the answer is what? Nobody?
0.8.
That is where the problem lies. I will shock you now. Some of you have some ready-made answer.
I have 1.6.
Okay, and you hear that probability should not more than 1. Where do you get 1.6? Better close your eyes.
Sir, please, I can't see the question again.
Yes, it has disappeared. So another question, please look at this question.
If A and B are mutual.
If you don't need to read it for me, keep it to yourself, please. If A and B are mutually exclusive events with probability 0.3, probability of A is equal to 0.3, probability of B is equal to 0.5. Then what is the probability of A intersection B? Aha. So if you are the type that normally cram the solution, or you just ask your friend and they tell you and you quickly rush. So please give me the answer you can defend, because I will call your name.
0.8, sir.
0.8.
Which one is 0.8? Who is talking? Raise up your hand and on your video. Let me see your face. You can't see your face now. Who is talking? Okay.
So for the first question, 0.8. The
Just
second
hold
one,
on.
0.
Okay. Wait. Let me add you. Okay. What's the name, please?
Abimbola Ogunbadejo.
Okay, Ogunbadejo. So go ahead. The first one says probability of A union B is equals to what? And the second one says probability of A intersection B is equals to what?
That's 0.
The probability is, which one is 0?
The first one, 0.8. The second one is 0.
Okay, we are coming to that. Thank you for your own submission. Naomi, where is your face? Sorry. Talk.
Okay, the second one, sir, is 0.8, sir.
Which of the second one? Probability of?
Yes, of A intersection B.
0.8, right?
Yeah.
Okay, the first one.
The first one, that was the one I was telling you that I didn't see the question again.
Oh, okay, thank you. God's power.
Sir, the first one is 0.
The first one is 0.
0, yes, sir.
What is the first one? Probability of what?
That of 0.3 union 0.5.
Okay.
Yes, sir. So
okay.
the second one is 0.8.
0.8. Okay.
Yes.
Okay, that's fine. Let's stop there. Omolara Jaye Oba. Jaye Oba Omolara, are you there? We can't hear you, please, if you are talking.
Hello, sir.
Yes.
The first one is 0.15.
Sorry, who is talking?
Jayoba.
Oh, okay. Go ahead.
The first one is 0.15. Why the
0.15?
Yeah.
We can't see your video too. Or you don't want it? We can't see.
I've done it.
Because I want to see the mathematician, some of you talking here. You always talk behind the door. Okay, the first one, Ibokun, 0.8, second one, 0. Okay. We will see now. I'm only waiting for this, the madam to talk.
Yeah, I'm trying to start my video. It's not
no,
working.
just continue. Continue your talk.
Okay, the first one is 0.15. Why the second one is 0.8?
Okay. Oh, it's fine. 0.15, 0.8. Okay, ask down everybody. It's fine. Let's just quickly go to the board, please. You can lower your hands.
0.5.
Okay, let's go back to the definition.
Sorry. Sir, please, can I correct myself?
You said?
Can I correct myself? That second one is 1.
No, that one has gone. No, you can't correct.
That second one is 1.
That second one is what?
Is 1 because the question said they are mutually exclusive events.
Any two events are mutually is 0.
The second one is 0.2.
Don't worry now.
0.5.
I've had you.
0.
Please.
0.5. Okay.
So, remember the question. The first question says, probability of A is equals to 0.3. Then probability of B is equals to 0.5. Please take notes. And the question because he said, if A and B are mutually exclusive, look at it. Are mutually exclusive. Then the probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. And I know that, lecturer 1, can you please mute yourself? And I know that At this point, what you need to know, these are the common questions. At least I've not seen it in all the years that I've seen. I've seen it 3 or 4 times. So they are very simple questions. Definition of this one, we know from here, he said, you should note that if 2 events are mutually exclusive, their intersection will be 0. And I ask you, what is the probability A intersection B? On a normal day, this particular one is probability of A union B is probability of A plus probability of B. Since that this one is already what? 0. Now, what is probability of A? 0.3 plus 0.5. The answer is what?
0.8.
0.8.
0.8.
How many of us got it?
I got it. I got that one. No.
You got that one?
Yes, but the other one.
The other one, what happened to the other one?
0.2.
I did not get it.
The second one, who can tell us the answer of the second one now?
0.2, sir.
The second one is what?
0.2.
Who is talking? 0.2. Let me see your face.
Edit.
Edit.
Yes, sir.
Are you sure it's 0.2?
That is how I got it.
That's what you got. Another person, please.
It's 0.
The answer is what?
0.
Eberochukwu is what? 0. Good. How many of us, if you support the answer is 0, raise up your hand. Use your invisible hand. Yes. Use your yes, I can see. Okay, let's lower our hand. Lower your hand, please. Just lower your hand. If you know that you don't understand the second question, raise up your hand. Those ones that you don't know how it becomes 0, raise up your hand. Oh, okay. Oh, okay. That's fine. Jayoba, you told us the answer before, so why are you raising up your hand again?
I didn't. My answer was not 0.
Your answer was
so
not 0. Your answer was what?
Yeah. What's 0.8 for the second one?
Okay. You now want to know how it becomes 0. Okay.
Yes.
Now, remember the question says, find the probability. Please answer that, everybody. Find the probability that he said every mutually exclusive is what?
0.
Oh.
In the point here, look at this. This is what the law that we apply. The question says you should find this. They say you should find this one, right? And if they ask you to find this one and give you these two to find this one, this gentleman, how do you, there's nothing common to them. So everything that's supposed to come to them is supposed, there's nothing, if there's no element that comes to them, what will you put? The only thing that you happen at that point, the point of intersection here is 0. And they ask you to find the intersection, not the union. The one they ask us to find the union, we just add them. We know from the definition. Are you getting it now? So you just find, I hope you are clear now. The point of intersection of a mutual two events are mutually exclusive, the point of intersection is 0. Please take note of that. So let's move on.
So please, I'm still a bit confused. The first question you set and the second one, they seem to be alike.
They are not. One is union, the other one is intersection.
Okay.
Check the question again.
So how do we differentiate from under the properties of probability that he gave us? He said the first one mentioned that if the events are both mutually exclusive and collectively exhaustive.
Listen, and collectively.
Okay.
If you don't put that one there, then you don't need to apply the first one. That's why they put the notes.
Okay.
Are you getting it?
Yeah. Yes, I got it.
That's why they said, however, if two events are mutually exclusive, then the probability of A union B is equal to probability of A plus B. And you have probability of A already, and you have probability of B also. So all you need to do, add them together and get your answer. But if the question proceeds, that said, find the probability of A intersection B, please, the answer is 0.
Okay, sir. Thank you, sir.
You're welcome. So let's move on. Okay, let's look at this example. This is conditional and unconditional probability. And this example is, I think I will need to write it out for some of us, or it might not necessary, but I will still need to put it together so that you can. Okay, before then, there is this interesting question, which I believe some of us that we've obtained our form, our presidential form, will be interested in. How many of us?
That is me.
Who again? Who is contesting among you?
I'm contesting.
Okay.
It is Wisdom that is going for presidency.
Wisdom, presidency.
Yes.
Nika, you are also going. Okay, that's good.
Wisdom. I will make you a minister of education.
Oh, okay. And the ASU will continue striking, right?
God forbid.
When you did not release money now, what will happen?
I will release a hell of money.
Okay, let's wait till then. Okay, let's continue. So we have a question here. In a presidential election, can we write it down? In a presidential election, there are 4 candidates. We call them, the 4 candidates, we call them A, B, C, and D. Based on our polling, analysis, we estimate that A has a 20% chances or chance of winning or win of winning the election. Y B as a 40% chance of winning. The question is, what is the probability? What is the probability that A or B win the election? What is the probability that A or B win the election? Now, in this case now, it's a very funny question, and it's applicable to our day-to-day activities, like I said the other time. So, how do we go about this? The solution is, the first thing you need to know, we have the events. The event one, the first event is A wins. The second event is B wins. C wins. And D wins. So, but our interest is candidates A and B, or B. Remember the definition I gave us initially. The first thing is the events are disjoint since more than the events we are talking about here is disjoint. They are disjoint since more than one of them cannot win. It cannot occur. Remember, we only have one president. A and B cannot win together. Do you agree with me?
Yes, sir.
Yes, sir.
A and B cannot win together. Therefore, one person will surely win. If A wins, then B cannot win. That is how probability works. From the third axioms that I gave us, the probability of union of two disjoint events is the summation of the individual. That is, the probability of A wins or probability of B wins is the same thing as the probability of A wins union probability of B wins. So, what is the probability of A wins? What's the value? So it simply means that
20%.
probability of A wins plus, remember union, how do we get to union? From the definition I gave us in the earlier, I said union means what?
And.
And why intersection means and. So please take note. These are the things we'll be using. So here we have probability of A is what?
20% over 100.
Plus 40%.
40% over 100.
100.
Which is 60 over
100.
What is the probability that either of them will win? Or the probability of union is what?
0.6.
So that is what they asked you to do. That is what they asked us to do. Any question? Somebody raise up the hand. Yes, Alisu. Salisu Muhammad, you raise up your hand, unmute yourself and talk. Oh, sorry. Okay, let us proceed. Wale, yes.
So I want to just clarify something.
Okay.
We said that the probability of there are four events or four possibilities. So how come do we have 20%? Shouldn't it be 25%, sir?
No, don't mix it. Don't set another question for yourself in the exam. Follow what the examiner is asking you. The question is clear. He said, we estimate. They are the one telling us. You remember all these grassroots politicians, they will tell you, pulling 120. Candidate A might have 20% chances of winning that polling unit. They said polling analysis. Based on our polling analysis, that is, the events that have been occurring before that time, they already gathered the data and do a kind of simple mathematics, arithmetic, and say, okay, we have 20% chances here. So then at the 4, B has 40% chances of winning that election. So don't say it's supposed to be, since it's 4, they're supposed to be 25, 25, 25. No, they are not interested in candidate C and D. Probably they are nowhere to be found. Are you getting the point?
Yes. So I've seen it. I've seen my error. I overlooked 20% and 40%. Thank you, sir.
Okay, please take note of that. Yes, another question. Ugo, you raise up your hand.
Yes, sir. So please, what I want to get clarified is, okay, when you have
take your bath.
When you have a union, you use the clause.
Yes.
When you have intersection, you minus.
No.
You divide.
Says who?
Okay, what do you do when you have intersection?
Don't worry, we are moving there gradually. We have multiplication rule.
Okay, so union is plus.
Yes.
Union is plus.
Yes,
okay.
Take note of that.
Thank you. Okay, thank you, sir.
Yes, who is raising up the hand there? Wisdom.
Sir, please. Hello, sir.
I'm hearing you.
Okay, please, this 0.6, I just want you to clarify me more on how you get it.
No, just add 20 plus 40. You know, 100 is the same thing. They have, yes. So just take 100. 20 plus 40, 60. 60 divided by 100, it will give you this.
Okay. Then in a case of, if it is maybe this A and B, maybe A is 30, B is 40, that is 17. Can you get? Can we also get that 0.6, or it must no less than 60?
No, they are not saying it must be 60.
0.7.
It will be 0.7.
Okay.
That means the chances is higher. So this is their chances now.
Be careful. Okay. Thank you, sir.
You're welcome. Okay, let's proceed. Yes, Ugo, are you guys still raising up your hand? Can you lower it, please? Okay. So that is just on the election issue. But let's look at our manual again. So we have what we call conditional probability, and we have unconditional probability. We have conditional probability and unconditional probability. In this case, now look at this table. They said, suppose there are 70 secretaries, and you have this by sex, men, male, female, and the marital status, single, married, and they have their total. The first thing is the probability for you to be a male. Look at it. The probability of male is what? This, we have the grand total. This is what they call grand total. That is when you add both horizontal and when you add both horizontal, the one here, when you add them, it must give you this. And when you add this one, it must give you this. Or else your value is not correct. So we have, this is what we call grand total, GT. Now, the probability that they are all female, they are all male is what? The total of male divided by grand total. That is the 20 divided by 70. We give you the probability of male. 50. Then for the single, what is the probability for the single?
45. For single,
we have probability of X. Let me just use X as a single. Please mute yourself. We have 45 divided by, that is, the total of singles are, whether you are male or female, is what?
45.
45. 45 divided by 70.
By 70.
Which is your grand total. Please take note. You can see. Then what is the probability of married? The married is what?
25 over 70.
25 over 70. So in a conditional probability, they gave us this. There's something we call probability of A given B. The definition is probability of A intersection B divided by probability of B. That is conditional probability. Definition for conditional probability is this. So I'm trying to see how I can manage this space. For conditional probability, I'll write it again. The probability of A, this line means given. Whatever that is not divided. Probability of A given B is the same thing as probability of A intersection probability of B divided by probability of B. It always be divided by probability of what we're given. So, okay, if I say probability of B given A, what is it? It's the same thing as probability of A, a probability of B intersection. Intersection what?
Intersection.
A.
Divided by probability of
Of
A.
A.
Please take note of that. Take note of these two definitions. We will be using it. And that is the definition we will use throughout, that we use it to solve the problem of married and single that you have here. Are we there now?
Yes, sir.
Okay. Aransi?
Yes, sir. Today, so what you just gave us now, that means anything they say probability of, the B given, probability of B given A. There is something like union there.
It's intersection first. There are union when it gets to a point. Don't worry, when we get there, we will discuss it. By the time you are finding, I don't know whether your textbook cover it, but when we get there, because I want us to use these definitions to solve using this table. I believe we all have the table. If you don't have the table,
material.
In our course material.
It's in your course material, right?
Yes, sir.
Okay. If you don't have your course material, that means you are not supposed to be in this class. Anyway,
Page 140.
I don't want you to, I only need table from you because I know the thing is scattered. That's why I want to quickly correct it for you, so that you will understand what they are doing there, and you can also relate. Okay, let's move on. So we have probability of the first thing is, let me put it here. Okay, the first question says probability of male given married. I know before now, some of us will be calling it divided by. It's not divided. So we can go ahead and let me clear this. Given married is the same thing as probability of may intersection married divided by what? Probability of what?
Probability of married.
Married. Not may.
Married.
So the one you are given will be the one at the will be your denominator in this case. Just have that idea. I don't want to go into detail for your level. Okay, let's look at the table. What is the probability? What is the probability of may intersection married? Let's go to our table.
15.
Okay. How?
No, sir. We had the married and the single, right? Or male.
The point of intersection is, look at it. This is May. Let me use another.
It's 5.
Probability.
It's 5.
Let's look at it together. Now, let me pick this. Probability of May. May is here. May is here, right? This is the married. The point of intersection is what?
5.
This is where they meet. And the value there is what? 5.
5.
Take note of that. This is the point of intersection, 5. So it simply means we can go here and solve the problem by saying probability of May is 5. Probability of May intersection marriage is what? 5 divided by
5.
What is probability of marriage?
25.
Probability of marriage is what?
25.
That
5.
is the sum.
Married is 5.
Probability of marriage is here.
25, yeah.
Is 25. So let's divide it. The answer is equal to what?
5 divided by 25 is 0.2.
0.2.
2.
So that is the answer.
Please, can you come
5
again?
divided by 25 is 0.2.
Yes, thank you. You said what?
Please, can you
I
come
don't
again
understand
on
it
this?
too, please.
Come again. We
I
didn't
don't
understand.
understand this, sir.
You don't understand?
Yes,
Yes,
sir.
sir.
Yes, sir.
Wow. Okay. You need to first of all understand the question and the formula.
Okay.
If you don't understand the formula, there is nothing you can understand in this case. So it's better you get the formula right. The way we solve the formula, the way we write the formula. So let's look at the formula again. So we have the formula in this case. I've told you, anytime you are given conditional probability, when you have probability of A, they call it probability of A given probability given B. And A given B, this is what they mean. A given B. A given B means this. It simply means probability of A intersection B. Probability of A intersection B. Are you getting it?
Yes, sir.
Sir, A given B just means A given the condition of B. Am I correct, sir?
Exactly. So when you have A given B means, how do I define it? How do I define it? The definition is probability of A intersection B divided by probability of that condition you are given, that B. Then, if my condition is given A, it will be like this. Now, you now have a question says, probability of May given Mary. What's the answer? What is the formula for it? The formula is probability of male intersection marriage.
All over.
Over what?
Married.
Married.
That's all. So let's go to the marriage. Let's go to the table. Let's look at the point of intersection between them. From the table, that's where you see the value. Not from your head. Just get it from the table, please. The table is here. What is the, okay, what is the, if I ask you what's the probability of May intersection single is what?
15.
15, correct.
15, sir.
Because this is the point. This is May. Look at it. Don't say where are they getting it. It's simple. Let's just draw the line. Look at this line. and I draw the second line. Let me now pick let us say I draw this one down. I draw this one down. And so now the intersection at this point is what? Look at the point of intersection here. The first one is here. This is where they are meeting. The second one is meeting here. What is the value in that bracket?
5.
The first one
15,
is probability of male and single.
Single is 15.
Is 15. Are you
Yes,
getting
sir.
it? That is the point of
Yes, sir.
intersection.
Male
Is
given
15.
married is 5.
Then what is the probability of married?
5.
5.
The probability, the intersection between married and
And
male
male.
is what? 5.
5.
5.
I hope who is not clear at this point. I believe we all know it now. So we can go ahead and solve the problem. Then what is now the probability of marriage? Remember, the
25.
total will now be the probability of marriage. The total for marriage
25.
is what? 25.
25.
So we can go ahead and solve it now by saying all you need to do is just to divide. The intersection is 5 divided by 25. The answer is 0.2. That's all.
2.
Yes, who is raising up their hand? You don't write.
What Nani? Let's boost.
Sir,
What's your name? I can see Geomi, or what is it called?
Mr. Austin Inga, Mr. Austin.
Okay, yes, go ahead.
Yes, sir. My question is getting the total. You have to add the married and the male and the female to get the 25. That is from married. So that would be clear.
Which one?
That is married.
Yes. No, they already
because
give you
just-
the
we
total.
just-
You don't need to disturb yourself.
Okay, sorry,
The
sir.
total is here. You can only sum the married together.
Okay, sir.
We are not talking about marriage.
Exactly. That is what I was.
5 plus 25. 5 plus 20. We give you
Give you
25.
25. That is it, sir. So
Yes.
that will be more clear, sir. Thank you, sir.
So is that okay now?
Yes, sir.
So that is how you solve. Yes, Aransiola. Now, the question is another question. Yes, what is the question, ma?
I think I'm lost.
Where?
I got to this male and marriage, which is 15 intersection 5.
No. Look at it. 15 is for single.
Okay.
Yes. So if I ask you, okay, everybody calculate this. Probability that male given single. What's the answer, please? Everybody.
0.6.
15 over 45.
15 over
25. 0.6.
Any other? I hope you all got this.
Yes.
Any question?
Buy me orange.
Is that okay now?
Yes, sir.
Aransiola, can you get it now?
Yeah, it's fine now. Thank you.
No worries, Jerry. You don't buy finish.
If you are buying something, mute your this thing or mute your mic. Mute your mic. Are you buying for everybody?
Are you? Okay, let's continue. Now look at this question here. They said, using the table in example 3.1, calculate the following probability of getting a male given that is married. So meaning that male, probability of male, the first one mathematically is probability of male. We've done it, married, given married. Let me just clean this. Number one, I want us to solve it. Probability of male given married. Number two,
You have done that one.
probability of single
and female
given female. Number three, probability of marry secretary given that is a male. It's still the same thing. Is a male. Have you seen it now? Then probability number four, probability of, they can just give you a simple table and ask you to compute this. It's just a punch calculator and you get your answer and you go. Probability of female given single. So what's the first answer? We've done number one. Number two, what's the answer? Number three?
0.6.
0.6.
Number three?
Hold on, sir.
Wait, how come it's 0.6? Mine is saying 0.3.
Hey.
Is a question.
But 0.8.
No, it's 0.6.
Number three,
Number 3,
0.2.
0.8.
0.2.
The answer is number three is what?
0.2.
0.25.
Okay.
0.2.
0.2, number 3.
Number 3 is 0.25.
0.25.
Number 3 is what?
0.25.
0.25.
0.2. 0.25. 5 divided by 20.
5 divided by 20. 5 divided by
0.25.
5 divided by 0.25 equals to 20 now.
Okay.
So we don't have a lot of mathematicians now.
Number 4 is 2/3.
So I don't know whether you copy your textbook or not. I don't know, but let's look at it together. The probability for number 2 is probability of single intersection female, right?
Yes.
Divided by probability of female. So the answer will be what? What is the intersection single intersection female?
30.
30. Do we all agree?
Like 40.
Yes.
Yes.
Yes,
Somebody's
sir.
getting 40 already.
Yeah,
Divided
45.
by
55.
probability for female.
50.
It's 50.
Is 50, not 45, because you are only calculating
30 divided by 50.
Yes. That is why divided by what? 50. What's the answer?
0.6.
0.6.
So number 3, what's the answer? Do we all agree now?
0.25, sir.
0.25. Why number 4 is what?
0.67.
Is 0.67.
67.
67.
0.6.
2 over 3.
0.666, which is equal to 0.67.
30 divided by 45.
So is female
Over single.
intersection single.
Yes, sir.
And divided by single, right?
Yes,
Yes.
sir.
So it's going to be what?
0.
Intersection single, let's see, is what? Female intersection single.
30.
30
Yes, sir.
divided by
45.
45.
0 point.
0.6.
It's still 0.6.
0.67.
No,
Remember,
0.6. No 7. Don't follow course material.
It's 6, 7. No.
it's not
30 divided by 45.
It's not than 4. So
It's 6, 7.
6.
6, 7.
0.666.
You have to approximate it since it's more than 1, since it's more than 5. It's not the issue of don't follow the course material, it's the issue of is it right?
More than, yeah.
Are you getting it?
Yes, sir.
Okay, thank you for this. I believe it makes sense now. You can see probability is very cheap. It's not hard the way you think. So you can lay your hands on so many questions and make sure you solve them. Lastly, yes, GP. Who is GP now?
It's God's power.
Yes, what's the question?
Okay, this number 2 is still kind of confusing, of getting a single that is female.
So what is confusing there?
Because I got 0.67.
And that's what we got.
Okay.
Are you okay with that now?
Yes, sir.
Okay.
0.6. So
that one is 0.6
divided by 50.
0.6
divided by
Number
50.
2 is what he's asking of, which is 0.6.
It's 30 divided by 50, 0.6.
Is it 30 divided by 50 or 30 divided by 50? What?
Sir, number two is 30 divided by 50.
Divided by 50.
Which is
0.6.
0.6. While number 4 is 30 divided by 45.
45.
Which is 0.67.
0.67.
Correct. Everybody is correct. Everybody, you are all correct.
What 0.6 and 0.67?
You see, on that day when you are with your lab system, you will not argue with anybody.
Yes.
So, but can we approximate?
Everybody will be right.
Yes, we
You
approximated.
need to approximate.
If you use over 50, there's nothing to approximate there.
Okay, for example, if your answer, wait now, let me shock you with this. If your answer is this, let's say x is equal to 0.6666 and another x is equal to s.6111. What is the answer for the first one?
0.67.
0.67. Even let's say this one is 4. What's the answer?
0.6.
0.64.
Your home. Bye-bye. Yes.
What about a situation whereby instead of 0.67, they put 0.7 in the options? Is that not possible?
That's a very good question. Please, you have to be sure. Once they put that question, put 0.6.
Okay.
If the option says 0.67, 0.66, or 0.7, oh, let's say they will not confuse you to that point. They will just put 0. If you can only say 0.7, meaning the examiner has approximated everything.
One decimal place.
One decimal place. So, but if they put 0.67 and 0.70, please pick 0.67.
Okay. All right, sir. Thank you.
Yes.
So that is the reason why playing Baba Jebu or Lotto will fail someone. So please don't try it.
Okay,
just
sir.
make sure you do your normal calculation, and I believe you pass. It's very simple. Okay, let me just quickly solve the last question before we call it a day. This one, I will have to explain some things to you so that is just okay. Before then, let me lay this foundation. Number one, remember I said for any event A, for any event A is what? Remember, that's the first thing. It's the same thing as
probability A is greater or equal to 0.
Greater or less than
or
0.
equals to 0. Is probability A is greater or equals to 0. It simply means that the complement of A is the same thing as 1 minus probability of A. Please take notes. Take note of this definition. That is, the probability A does not occur. That is, if the event does not occur, it's okay. What is this simply mean is probability of A plus probability of A complement is equals to 1. If I now want to find probability of A complement, no, sorry. This is what I'm trying to say is when you said event will occur, we all know that the probability is 0 less or equals to probability of events less or equals to 1, right? That if that event will occur, it simply means it's 1. Now, if I now say the event will not occur again, it simply means I'm saying from the sample space, I said probability of S is equals to 1. Now, for the event not to occur, that is why we use this. We use the 1 in bracket. That is, note that the event will not occur means the complement. is one. Remember when we are doing set theory, go and watch that video again. Set theory video. Watch it again and again. It will help you and help you to be able to relate what we are doing. It's still the same, it's still continuation. So when I now said probability of 1 minus A, that is probability of success and failure. If this is the probability of failure now, that is 1 minus probability of success will give you probability of failure. That's simple. Then what's the probability of empty sets is 0. The probability of empty set is 0.
Yeah.
So what about when you have probability of A minus B? Probability of A minus B is the same thing as probability of A minus probability of A intersection B. Let's take note of that. Now, let me give us this question. Suppose, it's a very good question, which all of us, we are going to discuss it together. Suppose we have the following information. The following information, please. Number 1, or Roman figure 1. There is a 60% chance says that it will rain today. Some of us that have Owambe today will not pray for the rain. Number 2, Roman figure 2. There is a 50% chance that it will rain tomorrow. Number 3. There is a 30% chances that it does not rain either day. It does not rain either day. The question answer is find the probability, the following probability. A, the probability that it will rain today or tomorrow. B, the probability that it will rain today or okay. The first one is it will rain today or tomorrow. The second one will be the probability that it will rain today, but not tomorrow. C. Find the probability that it's either will rain, it's either today or tomorrow. But not both. So let's write the question, and somebody should tell us what to do first.
Please, the number 3 question is not very clear, sir. The C.
It's there now, but it's not clear there.
The probability that
I think the question where you omitted the rain, that's why the person is
the probability
okay.
There's an omission.
There's an omission, thank you. Probability that it's either the rain today, just put the rain there. Are you getting it now?
Yes, sir. Yes, sir.
Yeah, let's do the working, Jerry. Mo network burúkú ìbáyìí tó ti jẹ́ kí pajápajá mú mi.
Wàá ti mọ àwọn ọmọ ẹ. Oni, you are from where? Madam Pajápajá.
Either Oyo or Ekiti.
This is Ekiti for sure.
Ekiti. Are you from Ekiti?
Don't try to spite them.
I put myself, sir, now.
Oluwakemi.
It can be from anywhere.
You are from where?
Sir, I mute myself. Oh, I don't know why you can hear me.
Okay. I'm not the only one that hear you. The whole nation hear you, so I'm not the one.
We have how.
You are from where?
Ekiti.
You need to do Pandedian for me.
Ekiti, sir.
Which of the village?
Sir?
Which of the Ekiti?
Which part? From Oye.
No wonder. Pajápajá is too much there.
We are in that period now already.
Sorry, sir.
Can you get? I hope we all have the question now.
Yes.
Yes.
Okay. The first thing we need to do, you need to solve it by saying solution. The solution will be, what's the probability of the first? What's the probability of? Let's represent them. It will make your work easy.
Provider will gain today.
Let A represent event that, please write it down. Let A represent event that it will be rain today. That is for us to say, okay, A equals to rain today. Then B equals to rain tomorrow. Twice.
There's no rain either day.
Now, if you want to, that's the only 2 days we have.
No.
Yes or no?
So what about
Yes,
Yes,
sir.
sir.
Have the one that will not rain either
Yes,
the
sir.
day.
No, we only
You
have
cannot
this
represent, remember, either of the day you are talking about, there is no C in this case.
Yes, sir.
It will only be, either of the day will be, is either today or tomorrow.
Tomorrow.
So, where you are, please mute yourself. Just mute yourself for the peace of others. Jai Oba and Co. Mute yourself. Okay, so we have it this way. The probability of A, who can tell us from your question?
0.6.
Is what? How many percent are we talking about?
60%.
60%.
60%. 60 divided by 100 is 0.6. Because if it's just a 0.6, people will ask you question, where do you see it? Then probability of B is what?
50%.
50%.
0.5.
Yes. Then the question now says probability that there. How do we write Roman figure 3?
That's 111.
30.
Elizabeth, I will send you out again if you don't mute yourself. So if I ask question, please answer and mute yourself again, please. So probability, how do you write this one in probability? If you know the answer, raise up your hand so that I'll call you. I'm waiting. Nobody? Yes,
Sir,
Rafat.
probability of what, sir?
probability A union B?
A union B. No. Remember, union can be addition. Read the question. Said there is
probability A and B.
How do you represent it mathematically?
Intersection.
Intersection, right?
Yes, sir.
Yes, sir.
If it is
Minus
intersection,
complement.
Probably A
now
intersection B.
A intersection B. No. Remember,
Yes, sir.
Union is
Aliyu.
or.
Sir, A given B.
No.
Once an union is or, and we are talking about either today or tomorrow.
Abimbola.
Is B is equal to A complement B.
Okay,
No.
let me. It will be probability A union B over.
B.
It's not conditional, remember.
Okay.
The question says there is a 30% chance that it does not rain either day. When they say it does not, something it does not happen. Remember, I gave you definitions here. Look at it.
That is you.
The probability that event does not occur is what? Probability of A complement. So it's going to be A complement intersection B complement. Because we are talking about either of the two is 30. Any question? Now, this is just the definition. Let's look at the question A now. The probability that it will rain today or tomorrow. How do you explain that? Abimbola Shehu.
So that's union, sir.
Is what?
Union.
Union.
Is union. Thank you.
Union B, yes,
So
sir.
A will be the probability of A union B. Because he said the probability that it will rain today or tomorrow is A union B. Now, what is the definition of A union B based on what the definition we've been talking about? A union B based on what the definition of B based on
A plus B.
No, in this case. Remember the probability. Remember this event. I gave you the definition, right? Now, I will explain something to you. It's similar, but what happened is the assurance event, the probability that will be rain today or tomorrow will be the sure that there will be rain minus the union, the complement of the union. You remember now. This is, let me explain myself. Look at this. This is the probability that event will occur is A. It's probability of A. We now say it's greater or equal to 0. Then how do we know the probability that it's not going to happen again? It will be, according to the Morgan's law, which I want you to go and read, is 1 minus probability of A prime intersection B prime. Or, okay, let me first of all define it this way so that you understand what I'm saying. It's the same thing as probability of A union B prime. Remember, we said probability of A dot is the same thing as 1 minus probability of A. Are you getting it? So if the event does not occur, we now said is this. That is, find the complement of that will be the value of the event that occur. So what we mean by this, we already have the definition for this. According to the law, the Morgan's law, is there, we can say that 1 minus probability of A in prime intersection B prime. And at the end of the day, 1 minus, what is this? What's the definition for this?
0.3.
Is 0.3. We have it because it's given.
Yes, sir.
So the answer will be 0.7.
0.7.
Any question?
I don't understand, sir.
It is actually long but straightforward, of course.
It's a straightforward thing. It's just a simple thing. I will share the screen again. What it's saying is there will be rain. The question I said, what is the probability that the rain will be? Is it that today? There will be rain today or tomorrow. But on a normal day, I have the definition for there will not be rain in either of the day. So how do you treat that? That is what we just did now. But let's look at the second one.
The first one is not clear, sir.
Don't worry, just write it down first. And by the time I'm explaining again, we go over it again, you get it right. I've told you the definition I gave you. Probability is all about definitions, not the one you crack. Please take note of that. B. The probability it will be rain today and tomorrow. We know the definition for rain today and tomorrow to be what? A. Anybody?
A union B.
Wow.
A intersection B.
Intersection
A intersection B.
0.6 and 0.5.
Is what?
And 0.5.
Mr. Solomon, what are you trying to say?
The probability, that's also a probability that it will be rain today. To rain today will be 0.6.
Yes.
Not rain today. It is 1 minus 50, 0.5. It's also 0.5.
Okay. And what?
That will be 0.6 multiplied by 0.5.
No, okay, thank you. Let's just look at this. The probability that will be rain today and tomorrow is probability of A intersection B, agreed. But we need to define probability of A intersection B. It is, I've told you, it's all about definition. For you to define this, you have probability of A plus probability of B minus probability of A union B. Probability of A plus probability of B minus probability of A union B. Please take note of this. We know the probability of A to be what?
0.6.
0.6 plus probability of B
0.5.
minus probability of A union B
0.7.
Remember, you've done it.
Yes.
0.7. Yes.
Yeah. Now, I will explain. Either of the two, the day 1 and day 2 means probability of day 1 plus probability of day 2 minus probability of union, the union between them. Remember when we are discussing about mutually exclusive, and remember when we are discussing about mutually and the other one that is not mutually exclusive, you remember the definition. So please take note of this definition when you have and when you have or in the Morgan's law. Please, let's take note of that. So what is the answer of this?
0.3.
0.4. 0.4.
Is 0.4.
Yes, sir.
0.4, yes.
Now, the C part of it, before we go over it again, the C part of it is what? The probability it will rain today, but not tomorrow.
That's the B. That's the B part.
That will be rain today, but not tomorrow.
That's what we just treated.
No.
You are missing it.
Yes.
Sorry, sir. How do you get 0.7?
0.7 is union, the one we calculated in B, in A. You remember? So, this is the question, the third question, or the last question says what? The probability that
It will either rain
It's either we rain today or tomorrow, but not both. And I've now reading the question, and I said the probability that it will be rain today, but not tomorrow.
That's question B, sir.
Question B says what?
The probability that it will rain today, but not tomorrow.
Okay. The one we solve now is what?
The one we solve now is not in the question.
Oh, it's not in the question. I just
Yes, that's what I was trying to say.
Okay, thank you so much. Because I remember they did not ask for that question on set. Thank you. Please put it there. Is for the and. So the second question will be what? The big question will be what now?
The probability that it will rain today, but not tomorrow.
But not tomorrow.
Okay, it's going to be probability of rain today, which is A. So what will happen? Union or intersection?
Union.
Union.
I've told you, union will only carry or.
But not what is intersection.
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 But not B prime.
Compliments.
Thank you.
Compliments.
But not tomorrow. But it's still going to be intersection, but not tomorrow. Are you getting it now?
Yes.
Yes, sir.
So which is the same thing as what? Probability of A minus B. It's the same thing as probability of A minus B. So in your book, is there, go and sit down and read that probability of A minus B. Or you
That's
do it.
0.1.
Is what?
0.1.
Is 0.1. Where do you see it? What is the definition for probability of A given minus B? I gave you here. I put it somewhere. Okay, it's here.
It's 0.3.
Is probability of A minus probability of A intersection B. So that is the definition. Is probability of A minus probability of A intersection B. Now, if I ask you to do what is the probability of B minus A, what is going to be the definition?
Probability of B.
It's going to be?
It will be probability of B minus B, sir. Minus probability of B intersection A.
Union.
That's all. Definition is just to blow it's just a grammar, but by the time you merge it together, it's still going to be the same thing. Now let's go. What is probability of A?
4.6 minus 0.4
minus
0.4
0.3.
The answer will be
0.2.
So can someone explain how to solve the last one? Do I need to call you? How do we solve the last one, please? If you know, if you have idea, just idea. I'm not saying you should get a perfect question, perfect answer. Just raise up your hand. The question says what? Find the probability that it's either
to rain today.
Will rain today,
or tomorrow, but not
or what? Or
not
tomorrow,
both.
But not both. Yes, Moshood.
Thank you, sir. The last one is probability of A prime intersection B prime.
Probability of A prime
intersection B prime.
Can it be like that? Let's, okay. Probability A prime intersection B prime. Remember, they said either rain, it will be either will be rain today or tomorrow, but not both. Who can try? Any other person? Yes, Aronsi. You said is a wrong calling.
that will pass our minds.
No.
Let me give it a try. What I think, sir.
Go ahead.
I think it's the complement of the probability of A union B.
Complement of
A union B.
A union B. Remember, it says but not both, right?
Yes, sir.
A union B. You all know that is a union.
Yes, sir.
Either A, probability of A union B, but not both. So what's the but not both?
But not both.
Who can give us the definition here? Is probability of A union B is what?
.7.
But not both. Is that probability of A union B? He said either today or tomorrow, which is this, is the same thing as probability of A plus probability of B minus probability of what? Excuse me.
Minus probability of A intersection B.
Do you need prime?
No.
At least I've solved it halfway. Go and complete it.
Please complete.
I will not complete it.
Yes.
It's just intentional. Because remember the way we solved this one.
There will be prime.
No, look at the
look
at the first one. B, the B part. I intentionally solved the B part. Remember, the B is not part of the question.
Yes.
I slaughtered the B into it, put the 2 there, the B there, so that you'll be able to solve this problem. That is the secret. I won't say more than that.
Okay.
So what is the answer? Like that.
You have seen the fish already.
What's the answer now? Why are you laughing?
I share the screen.
As you share the screen, which screen again?
Sir, it is A intersection B, sir.
What's the value for this one minus this?
Yeah, 0.7.
Is what?
0.7.
0.7. Okay. You might be wrong, you might be right. Congratulations.